Hello, can you all hear me?
Yes, you're
Yeah,
audible.
yeah, okay. So, hi, I am Nikita. So, for today's live session, I will be taking it out. So, we can start posting it. Either you can post the doubts in the chat box or you can ask me directly. So, if you have any doubts from week one, you can ask me. Anyone? Nobody has doubt in week one? How many of you have watched the lectures for week one?
I have a problem in tutorial question number 14. Tutorial 1, question number 14.
Okay. Let me check. Uh, can you mute yourself? Please mute yourself. Yeah, so question number 14, it says pack of 5 items is known to contain 2 items that are defective. So you have 5 items in which 2 are defective. And now what you want to do is you want to check the items one at a time. Like you pick one item, you check whether it is defective or not, and then keep it aside. So until you get the defective items, you keep on checking it. So what is a random variable x denotes? It denotes the number of tests made until the first defective item is found. So there are 5 items in total, and you want to check what are possible values x can take. So you want to test the item. So either you can obtain the defective item on the first trial or the second trial, the third trial. It can go maximum till fourth trial. And what is it? It cannot go to fifth trial because you have 2 defective
Hello.
items. Yeah.
Sorry to disturbing. Which question we are discussing?
Question number 14.
From question number
Wait,
14.
tutorial one. Wait, I will share the screen.
Once more, please once again.
Tutorial 1,
Tutorial.
week 1, question number 14.
Oh.
Okay. Yeah. And so there was a mistake there in the question that like why denote the additional number of tests? It was written as an additional number of tests, but it is actually the number of tests that you have to make until the second effective item is obtained. So it can be either one item. So on the first trial, you cannot get the second effective item, right? So it will start from second, third, fourth, and fifth. Now, what you have to find in question number 14 is find the value of probability x equals 1, comma, y equals 3. It means the first defective item is obtained on the first trial and the second defective item is obtained on the third trial, right? So, how many of you know the geometric distribution?
I know that, ma'am.
Okay, hold on, I will share my screen. So we have to find probability x equals 1, comma, y equals 3. So what does it mean? It means the first effective item will be obtained on the first trial and the second effective item will be obtained on the third trial. So in a total of 5 items, you had a total of 5 items, and out of those 5 items, 2 are defective. So what is the probability of getting a defective item?
2 by 5.
2 by 5, right? So if I'm
Yes,
saying the
ma'am.
first effective item is obtained on the first trial, what is the probability?
1 by 4.
1 by 4. Why is it 1 by 4? The first effective item on the first trial. First trial means like you have picked an item from, and that item is found to be defective. What should be the probability?
1 by 5 then. No, sorry, 1 by 2.
It is
Actually, I'm confused.
2 by 5.
2 by 5. Yeah, because total number of defective items in the lot are 2, right? And total number of items is 5. So in the first trial, you have 2 defective items in the lot, and you have to pick one item, and you have to find what is the probability that the item is defective. So that is 2 by 5. Now in the second trial, you are not getting the second defective item, and it is without replacement, right?
Yeah.
Yeah. So if you are if you are doing the second trial and you are not getting a defective item, what is the probability? So you have removed one item from here. Now you have 4 items, and
2 by
one
4.
defective item is already gone. So there are one defective item that is left in this 4 items. So what is the probability of getting non-defective item?
3 by 4.
3 by 4.
3 by 4. Yeah. And on the third trial, you should get one defective item. What is the probability?
1 by 3.
1 by 3.
1 by 3. So this is your answer for the
Okay.
silver cotton.
Okay, got it.
Ma'am?
Yes, what is the chart box? Okay. Yeah, you can. Who is that?
Similar type of question. In the previous question, it is given that
Hmm.
in question number 15, it is given that the p of x equal to 1 and y equal to 3, that is given 2 by 5 into 3 by 4 into 2 by 5. So shouldn't be the last 2 by 5 will be 2 by 3.
Where?
In question
In
number
the question
15.
number 15.
Yes, ma'am.
What is
In the
question?
solution,
Oh, x equals 1 given y equals 3.
yeah.
Okay. In the solution, what is given? Okay, so there's a problem here.
Okay, ma'am. And the other thing is, I understood what sir did in the Poisson distribution in week 0 of part 3. But in week 1, he discussed in marginal PMF of discrete random variable. In week 1, he discussed a part of Poisson that I did not understood.
Which week, which lecture you're talking about? 1.4, is it?
Yes, ma'am. In 1.4, example of joint marginal and conditional probability, he discussed a scenario of Poisson distribution.
So you had doubt in where he discussed about Poisson number of coin tosses.
Yes, ma'am. I have doubt in the value of lambda and with k especially.
Okay.
What there were two variables. One was
Yeah.
lambda.
So what do you understand by like if I say a random variable x is a Poisson random variable?
Yeah, that
Do you
is
know
that,
the
that also I did not understood.
Do you know PMF of Poisson random variable?
PMF of Poisson random variable. Yeah, in the week 0 of part 3, the things that were discussed there, I understood that part. But other than that, I did not understand anything about Poisson.
Okay, so see, if you look at the PMF of Poisson random variable, say it is e to the power minus lambda. Like a random variable is taking the value k. It means you have k number of successes in a particular time period. Is equal to e to the power minus lambda, lambda to the power x by x factorial. So
That is for one value, right?
for yeah, like if I say x is a Poisson lambda, okay. So lambda is the rate. So you have like in a specific time period, what is the rate we're talking about? So if I say the random variable x is taking the value k, so x can take the value, if x is Poisson, it can take the value 0, 1, 2. Number of successes can be go till infinity, right? It will start from 0, 4, 1, 2, and so on. So for a specific k, for a specific value of k, it is e to the power minus lambda, lambda to the power x. Sorry, here it is k. K by k factorial, right?
For a
Now,
specific value.
if yeah, so if you look at that example, you're talking about the Poisson number of coin tosses. So
Yes.
what we are saying there is you have a random variable n that is following the Poisson distribution with the parameter lambda. Now, given a particular value of n, let's say n is taking the value n, okay, same as like x is taking the value k, right? So given n is taking the value n, you are tossing a coin n number of times. So let's say if n is taking the value 1, you will toss the coin 1 time, right? If
Yes.
n equals 2, you will toss the coin 2 times and so on.
Yes.
So what you will observe is you have one more random variable that is defined, that is x, and that random variable, so if this random variable is depending on the value of that n is taking. So what does it denote is like if n equals 1, so this denotes that in one, if n is taking the value 1, you will toss the coin 1, and how many heads are how many heads are possible in one
Yeah.
toss, right?
Yes. Yes.
So it can take either value 0 or 1.
Mm.
If
Yeah.
if n equals 2, it means you are tossing the coin 2 times, and you are observing the number of heads possible. So 0, 1, 2, right? So
Yes,
as you
ma'am.
can see that, if you go on, you can see that given n equals n, this x given n equals n is following the binomial distribution, right? This is clear. Why is it binomial?
Yeah, because there is only two value possible. So
No, see, what is binomial? In a binomial is like what we have a certain number of repeated Bernoulli trials, and all the trials are
yeah,
independent.
it's a Bernoulli trial, and
Like,
that's why it will come under binomial.
okay, so this will follow a binomial distribution, right?
Yes.
Now, what you had to find is f of n of x n comma k. You had to find the joint distribution of n and x, correct? So what is that? This is f of, So can you tell me what can I write here? So if you have seen the lecture, we have watched the lecture. So there is a relation between joint distribution, conditional distribution, and marginal. Can you tell me the relation? What should I write here?
I mean, for conditional we can use write it using conditional distribution like f of n for x equal to 1 plus x equal to 2 plus dot 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 x equal to n. We can write in that way.
I didn't get that. Can you repeat again?
Yeah, I mean, let's say the first value be f of n, f of n given x equal to 1. I mean that means the condition is x equal to 1. Sorry, f of x given n equal to 1. So I mean, what I'm trying to say is first we find the PMF for n equal to 1, then find the PMF for n equal to 2, then go on for.
So, see, let's say if I'm giving you that xy has a joint distribution, fxy, say t1, t2. Okay. And I'm interested in finding f of xy, t1, t2. So what can we write it as is f of x given by
T1 y equals to T2 of T1 and times f of
y of t2.
T2. Yes.
What else we can write?
F of y given x equals to T1
Into
at T2 and fx
y of
at
fx of t1. Right?
yeah T1.
So similarly, in this problem, we know the distribution for n, we know the distribution for x given n, right? So we can write f of n of x. Let's say n is taking the value small n and x is taking the value small k. So this we can write as f of x given n equals n of k into f of n of n.
Yeah.
Right?
Yes.
And this we know, and this we know. So you just have to substitute the values that it takes. So this is what? This is n choose k, p to the power k. So n minus k, it will be just n into e to the power minus lambda, lambda to the power n by n factorial. So this will be your joint distribution. Okay. And then what we have to find is we have to find the marginal of x.
Yeah.
So see, so to find the marginal of c, if we have let's say we have a table, we have two random variable x, y. X is taking, let's say, value 1, 2, 3. Y is also taking 1, 2, 3. Some probability can write, let's say, B, C, D, E, F, G, H, I. Okay. So the sum of all these values should be 1. A plus B plus up to I should be equal to 1. So if I'm asking you, find the marginal of x. Let's say find fx of 1. So what do?
We add up the first column.
We add the first column, right? So if if we have to find fn, if we have to find fx of k, we had two random variables n and x, right? And we have to find the joint marginal of x. So what do? We will sum over all the possible values of n. So so this is sum over fn of x of n comma k. N is taking the value from 0 to infinity because n is Poisson random variable.
Yeah.
And your n is taking 0, 1, 2 up to infinity.
This part I didn't understand. Sir then says that n will be from k to infinity.
Yeah. Okay. Yeah. So this is n varying from 0 to infinity, and your if n is equal, if n is taking the value n, your x will take the value from 0, 1, 2 up to n. Correct?
Yes, ma'am.
Now, so let's see here. So if let's say x is taking the value k, so okay, so if your n is less than k, it means number of number of tosses cannot, if number of tosses is greater than the value of n, is this case possible?
No, no.
No. So what we are doing here is like for till n equals from 0 to k, sorry, k minus 1, this value will give the 0, right? This will give the value 0.
Yeah, if n is less than k, then it will get
Till k minus 1, from 0 to k minus 1, it will give the value 0.
yes.
So we'll only consider the cases from n equals to k to infinity, because before this k till k minus 1, it will give the value 0. So it is like there is no need to just write 0, 0, 0, right? So we'll take from n equals k to infinity. We'll just ignore all those n for which it is taking the value less than k. Is it okay?
Yes, ma'am, understood.
Okay. So fx of k, we will take n equals k to infinity fn x of n comma k. And in the previous slide, this here we have already found the value of fn x of n comma k. So we can just substitute it here, and if you solve it, you will get this is equal, this follows the Poisson distribution with the parameter lambda p. So in this case, if this example, p was 1 by 2, so you will get lambda by 2.
Ma'am, what will be the value of lambda in this case? I mean, in the previous weeks, in the previous weeks, like we were calculating the value of lambda by total number of value by total number of frequency, and we
So
were getting.
did you try to solve any problem from Poisson distribution part?
No, ma'am. Actually, I did not attempt any because
Yeah,
I
so
did not understand.
you should try to solve some of those problems like that lecture problems. So let's say if I'm saying n in this same example, if I say n is Poisson 20, right? So this is your lambda. This is a parameter.
Yeah, that I understood. But what I'm not understanding is in the previous example, like.
Okay. Let's see some problem from the. Wait. So that is week 0, but can you all see this?
Yes, ma'am.
Yeah, so let's look at the first question. So it says on an average, 240 ambulances arrive at a hospital per hour. So in an hour, 240 ambulances are coming. So we have to assume that number of ambulances arriving at the hospital follows the Poisson distribution. Find the probability that one ambulance will arrive in 30-second time interval. So what is given to us, like on an average per hour, in 1 hour, 240 ambulances are coming on an average. But so in this case, your lambda is like if you take the rate as 1 hour, so in that case, lambda is 240. But if you look at the question, you have to find the probability that one ambulance will arrive in 30-second time interval. So for 1 hour, on average, 240 ambulances arrive. So in 30 seconds, on an average, how many ambulances will arrive?
120.
120. No,
No. 2.
2, right? So
Yeah.
that will be your lambda.
Yeah. Correct.
And you have to find the probability that one ambulance will arrive in 30-second time interval. So x equals 1. So if your random variable x is representing the Poisson distribution, so probability that x equals 1 is what? It is e to the power minus lambda. So lambda is 2. Lambda 2 to the power 1 by 1 factorial. So whatever we'll get, that will be your answer. So just try to like solve the problems from Poisson distribution. It will be helpful.
Here you use the formula that total number of ambulance by total time taken, right, to find the lambda.
Yes.
Yeah. So in case of that tossing the coin, so what will be the total value and total time? I mean, what will be total value and total frequency?
That is not your Poisson distribution. That is not your Poisson distribution. So your Poisson distribution was x, no? Sorry, n. N was your Poisson distribution. N is some random variable that follows the Poisson distribution with parameter lambda. Now you have another random variable, like you are like given a value of n, you have a random variable x that denotes the number of heads that you obtain in n equals n number of tosses.
Yes.
So it is some random variable. It is not, you have no context given like why it is Poisson. It is not given in the question. It is just given it follows a Poisson distribution with the parameter lambda. And now given some value of that random that n, you have to find the number of, like you have to identify the distribution of x which denote the number of head that you obtain in n number of tosses.
This lambda can take any value, right?
Yeah, this can take any value. It depends on your question, but whatever sir has done in the lecture, he has not taken like in general he has taken n is a Poisson random variable.
Yeah,
So
he
if
has
you
not mentioned the value of lambda.
yeah, so if you look at the activity question, you will find one question where
Poisson 20.
Poisson 20 is given. Yeah. So there, while calculating, you can use this is your lambda now. Lambda equals 20.
Okay.
So n is some random variable that follows the Poisson distribution with the parameter 20.
So they are determining this value of lambda somehow, and we don't have to care how they are determining it, right?
If it is given to you in the question that x is some random variable that follows Poisson sum 20. So you just have to assume that x is a Poisson random variable and it has a parameter lambda. That's it.
Okay.
Could you explain about geometric distribution?
Yeah. Okay. So geometric distribution is basically the first success, right?
I mean, here like a first section in number of trials.
You have watched the lecture?
Yes, ma'am, but I did not understand.
Okay. Can you tell me what you understood from the lecture or about the geometric distribution?
Ma'am, there is a experiment. Like say for example, tossing a coin. You toss until you get the first head or something like that.
Yeah. So what is it like is you have to repeat the experiment until you get your first success. So let's say if I'm tossing a coin and let's say I'm defining my success to be head, getting a head, right? So like you toss a coin first time, you got, let's say, tail. You got toss the coin second time, got a tail. Again, you toss the coin third time, you got head. So that geometric distribution basically models like on what trials you are getting the first success. So either you can get the first success on the first trial, or you can get the first success on the second trial, or you can get the first success on the third trial, and so on. It will go on like that,
Okay.
right? So if your first success is on the first trial, so what is the probability? That will be 1 by 2. So let's say I'm writing p equals 1 by 2. Okay. So this is, let's say, p. What is the probability that the head occurs on the second trial?
1/4.
1/4. So this is basically 1 minus p into p, right?
Yes, ma'am. Yes.
What is this? So this is 1 minus p whole square into p.
Minus. Yeah.
It will go on like that. So this is what geometric distribution is. Like the first, like the trial on which you get the first success.
All
There's
right.
nothing much. Yeah.
No, what is the general? Is there any general formula for this?
No. There's no general formula.
All right. No. Yeah. All right.
Basically, it's, if I say x is a geometric distribution with the parameter p, and if I have to find probability x equals k, it means the k first success is on kth trial, right? So this is in the first k minus 1 trial, you should get the failure, and on the k trial, it should be a success. So this is like the general formula.
All right, ma'am. Yeah. Thank you.
Ma'am, can you please solve third question from lecture assignment 1.1?
1.1. Wait.
Yeah.
Check. The question number third. 1.1 question number third, is it?
Yes, ma'am. From a well shuffled deck of 52 cards. It starts with this.
Okay. Okay, so you are drawing 4 cards from a pack of 52 cards. 52 cards, you are drawing 4 cards from there. Now you have defined 2 random variables. So your first random variable x, that represents the number of queens that you will obtain on the like whatever cards you have drawn. Similarly, y denotes the number of kings. So can you tell me what all possibilities, what all the values x can take?
0 to 4.
0 to 4. What are values y can take?
Same 0 to 4.
0 to 4, right? Now you have to find fxy of 2, 1. What is this? This is probability that x equals 2 and y equals 1. It means on the 4 cards that you have drawn, there should be 2 queens and 1 king. Correct? You have drawn 4 cards and there should be 2 queens and 1 king. So how many queens are there in the?
There are 4 queens.
Huh.
So what we are going to do, we are going to do 4c2 upon 52c2 into 4c1. No, into 4c2. No, I guess I'm wrong.
Wait. So 2 queens should be there and 1 king should be there. So there are 4 queens. So it should be 4c2. You are choosing 2 queens out of the 4 queens. Now there should be 1 king. So there are also 4 kings. So you are choosing 1 king. So 4 choose 1. And since you have drawn 4 cards, there is 1 more card that is left that you have to select. Okay? So if you remove the queens and the kings, how many cards are left?
46.
No, it is 44.
44, yeah.
So out of those 44 cards, there should be 1 card that is not queen and not king, correct? And you had total of 52 cards and you had to select 4 cards. So total number of possibilities were you have to select 4 cards out of 52. So this is your answer.
Ma'am, I'm having doubt that how you selected 44 choose 1.
44 choose 1. See,
Yes, ma'am.
you had 4 cards. You have selected 4 cards out of 52 cards.
Yes, ma'am.
Right? Now, you wanted 2 kings, 2 queens, 1 king, and so this is what you wanted. Like, what is the probability that there should be 2 queens and 1 king? There are 4 queens, so you can select 2 cards. So 2 cards can come from there. 4 choose 2.
Yes, ma'am.
Out of 4 king, 1 king should be there. So 4 choose 1. But
Yes, ma'am.
2 plus 1 only makes 3 cards, right? There is
Yes,
1
ma'am.
more card that is left. So 1 card that is there, that should come from the remaining 44 cards.
Okay. Yes, ma'am. Got it.
Right?
Thank you.
Yeah.
Right,
Ma'am, can you
thank
explain fourth one also?
Fourth one.
Yeah.
What is the 4th one? Okay. Okay, I will ask you. Can you tell me what you have done? So we have g of xy equals xy by 9, where xy is taking the value in 1, 2. And you have to find probability that x plus y equals to 1. Can you tell me how should we proceed for this question?
Actually, ma'am, I did it a long time ago. I guess I did it 4 or 5 days before, so I still don't remember. But I have written all the questions which I wasn't able to solve.
You don't have to remember the problems. You should know how to proceed, right? At least, I'm not asking you the exact answer. Just if you can tell me what should we do here.
How is it that possible that you can add 1 and 2?
Yeah, exactly. That is not possible. So whenever you have the joint distribution function given to you, just do one thing. You just make a table, joint distribution table. So x is there, y is there. X is taking the value 1, 2. Y is taking the value 1, 2. And you just what is the joint distribution table? So 1 by 9. This is 2 by 9. This is 2 by 9. This is 4 by 9. X plus y, we are asking, find the probability that x plus y equals to 1. But given the values of x and y, no such value of pairs are possible. So that is why this probability is 0. Is it okay?
Yeah, ma'am, I got it.
Ma'am, can you explain question number 1 of activity 1.4?
Question number 1 of activity 1.4.
Yes, it is about somewhat range, and I didn't understood how to take out the range of that Poisson.
Okay, I have just explained the problem. See.
Yes, ma'am.
The question. Can you tell me the question? Can you?
Which one? This question number 1, ma'am.
Yeah.
Let me see, ma'am. What was the question? Maybe it's about the number of customers arriving at a shopping center in an hour interval is n distributed over a Poisson of 20. Assume the probability customer making purchase is 0.4 and the choice of purchase of customer is independent. Let x is the number of customers who are making a purchase. Then identify the range of x given n equal to n, small n.
So what is capital N there?
It is that interval now, that Poisson distribution.
It is not interval. It is a random variable that has the Poisson distribution with parameter 20. Okay.
Yes, ma'am. Yes,
now, what is given? Given the value of n equals n, let's say the random variable n is taking the value small n. And what is x? What is x?
It is a number of customer purchasing.
Number of customers making the purchase. And what is n?
It is a random variable.
No, like there is explanation about the random variable. What is that?
It's a Poisson random variable. Poisson random variable.
Yeah, but what does it represent? It represents the number of customers that walk into the shop, right?
At that interval. Yes, ma'am. Yes, ma'am.
Number of customers who are walking into the shop. So if I'm saying capital N equals n, it means n number of people are coming to the shop.
Yes, ma'am.
And what is capital X says? It says number of customers who are making the purchase.
So maximum can be n only and minimum can be 1 only. Okay, ma'am.
No, minimum can be 0.
Yes. Yes.
It is possible that you got it.
No one is purchasing.
Yeah.
And maximum can be that all are purchasing.
Yes.
Okay, ma'am. Thank you, ma'am. Got it, ma'am.
Can you please solve 1.7th assignment, 4th question?
1.7 assignment, 4th question.
4th question. Yeah.
Check the question. Okay. So, have you tried solving it?
Yes, ma'am. My answer is 3 by 4. So, okay. So let me tell you what I did. So as values are given, fx0 equals to 2 by 5, fx3 given x3 equals to 1 is 2 by 3, and we have to find another one, that is fx1 given x2 equals to 0 and x3 equals to 1. So what I did, fx1 x2 x3 0 comma 0 comma 1 equals to fx1 equals to 0 given x2 equals to 0 and x3 equals to 1 multiply by p bracket x2 equals to 0 comma x3 equals to 1, and though when both of these values are already given, so I did that, but my answer is not an option.
3 of 0 is 2 by 5. x2 x3 equals 1. 0 is 2 by 3, and you have to find fx1 x2 0 x3 1 of 0. Okay. Okay, let me share the screen. So fx1 x2 x3 of 0 0 1 is given to you to be 1 by 5, and this we can write it as this is probability that x1 equals 0, x2 equals 0, x3 equals 1. So we can write it as probability x1 equals 0. fx1 given x2 0, x3 1 into 0, right? And then we have probability x2 equals 0, x3 equals 1. So this is what we have to find.
Right.
Now, so this is going to be 1 by 5 divided by this probability x2 equals 0, x3 equals 1. Now what is this? This is going to be fx2 given x3 equals 1 of 0 into fx3 of 1, correct? So what is this fx2 of x3 equals 1 given 0? This is given to be 2 by 3. And what is fx3 of 1? That is not given to us. What is given to us is fx3 of 0 is 2 by 5. And what we have to find is fx3 of 1 equals what? So can you tell me what is fx3 of 1?
That should be 1 minus fx3 of 0. That
Yes.
is 3 by 5.
Yes. So since xi's are taking the value in 0, 1, and since fx3 of 0 is given to you, so fx3 of 1 should be 1 minus 2 by 5. So that is sorry, 3 by 5, right? So you just have to multiply 3 by 5 here. So this will get cancelled out and it will be 1 by 5 divided by 2 by 5. So it will come out to be 1 by 2.
Ma'am, can you please tell me why you subtracted fx3 from 1?
Because in the question you have given fx3 of 0, right? fx3 0 equals 2 by 5. But what we have to find here is fx3 of 1.
Okay, yeah.
And
Now I
xi's
see.
are taking the value in 0, 1. So the range is just 0, 1. And for 0, you are given the value 2 by 5. So for 1, it is going to be 1 minus 2 by 5.
Sure, ma'am. Thank you.
And can you please
Could you
explain
explain
question
about
number
the
1 of week 1 tutorial 2?
Can you go one by one? Yeah. Before that, somebody else was saying.
Question number 1 of week 1 tutorial 2.
Question number 1 of week 1 tutorial 2.
Yes, ma'am.
Okay. Question number 2, is it?
Ma'am, 1.
Question
First.
number 1. Okay. So it says a non contains n tickets numbered from 1 to n.
Yes, ma'am.
And 2 tickets are drawn without replacement. Let x denote the smaller, y denote the larger of the 2 numbers so obtained. Describe the joint distribution of x and y. So you are drawing 2 tickets. So you have so x denote the smaller of 2 numbers and y denote the larger of 2 numbers. And you are drawing, so there are tickets from number from 1 to n. And you are drawing 2 tickets without replacement. It is without replacement, right? Not with replacement.
Yes, ma'am, without replacement.
Without replacement. So what all values are possible for x?
1, 2, and minus 1.
Why is it? Is it
Because-
clear?
Because
Is it clear to you why it is n minus?
Because n can't be smaller of the 2 numbers.
yes.
Yeah, sure. So x will take the value from 1 to up to n minus 1. Similarly, y will take the value, since y is the larger, so it cannot be 1. So 2 can range from 2 to n. Now, let's make the table. So this is y. So 1, 2 up to n minus 1, 2, 3 up to n. So if x equals 1, okay, if x equals 3 and y equals 2, it is going to be 0. So till this, all the elements, all the values are going to be 0. These are going to be 0. Now you are drawing two cards. So you have 1 to some n cards in there, and you are drawing two cards. So first card that you are drawing, what is the probability of getting? What is the probability of drawing one card?
1 upon n minus 1.
No, one. I'm asking just one card.
1
So,
by n.
1 by n. Right. What is the probability of drawing second card?
1 upon 1 minus n.
1 upon 1 minus n.
N minus 1, sorry.
N minus 1. Yeah. Now, it is possible that the first card that you draw is the smaller, or the second card that you draw is the smaller. There are two possibilities, right? To draw two cards, so to draw two cards, so you have to select one card out of two. You have to fix the number.
But ma'am, we are cancelling that possibility, no, where x will be greater than y.
X will be greater than y. Yeah, we are cancelling those possibilities. So for all those values, it is going to be 0.
It is going to be 0. So there is only one way we can achieve, let's say x equal to 1 and y equal to 2. There is only one way we can achieve that.
But there are two cards that you have to select, right?
Yeah.
And if it's, let's say, if I fix a smaller number, so what is the possibility to get a smaller number out of the two cards? That is one possibility. So to choose one.
Did not understand these parts, ma'am.
Okay, let me think about some other way.
I mean,
ma'am, you are fixing the smaller card, right?
Yeah.
I mean, let's say we pick two cards from the pile of cards, and whatever smaller value we get, we assign it to be x, and whatever greater value we get, we assign it to be y.
Yeah.
So now, I mean, now the calculation should be 1 by n into n minus 1.
But we don't know, like, the first card that you select is going to be smaller or is going to be larger. Right? So there are two possibilities. The first number can be larger, or the second number can be smaller, or first can be smaller, second can be larger. That is why we have to multiply it by 2, choose 1. Is there anyone else who has problem with this question?
This question or a different question?
No, this question. Or if you understood this question some other way, you can also explain.
No, ma'am, I didn't even start week 1.
Okay. So now you should start week 1. Man. It is already started today.
Yes, ma'am, I have been engaged otherwise, but if I start even now, I could finish within tomorrow. I can do that.
Okay, then fine. Yeah.
Ma'am, in the next question of this tutorial only, we have to find marginal of x. So can you please also explain that also?
So how do you find the marginal distribution? You just
Some
so you have, what do you have to find the marginal? You have to find the marginal what? Fx.
FX.
Fx, is it? Okay. So you will fix an x and add it over all the rows. Correct? So let's see. Plus x plus y plus 1, 2, 3. Let's see. Next one. Plus 2, 3. Up to 1. For everything, this is 2 upon n times n minus 1. For this, it is going to be 0, 0, 0, 0. For this, it is going to be again 2 upon n times n minus 1. This is 2 upon n times n minus 1. Again 0. Similarly, it will be 2 upon n times n minus 1. It will go till here, 2 upon n times n minus 1. So you will just have to add the rows. So it is what if fx of 1, if I'm finding fx of 1, it is going to be 2 upon n times n minus 1 till into n times, right? If I find fx of 2, just let me see the question once. Be sure of this. Yeah, this is correct. So if we do fx of 2, so it will be 1 less than n, right? So this is going to be n minus 1 of n times n minus 1. Sorry, this is not.
FX of 1 should be
This is
2
left for some general
upon.
case. We'll talk about some general case. So this is, let's say, k.
I mean, should it be k minus 1? Oh,
Sorry.
nothing.
Can you repeat?
No, ma'am.
Ma'am, in the first, when you said that fx of 1 is 2 n upon n minus 1, it should be 2 into n minus
n minus
1.
n, 1 n minus 1. Yes, it is.
Yes, ma'am, that's
Because
what I
it
was
is 2 to
saying.
n.
Yes, yes.
That's why. Okay, ma'am.
So it is 2 times n minus 1. That will be 2 times n minus 2. Similarly, it is 2 times n minus 3 into n minus 1. So it will go on like this. Correct? So for any general x equals k, it will become 2 times n minus k upon n minus 1. Is this correct?
Yes, ma'am.
Ma'am, can you explain week point 3, tutorial 3, question number 4?
Can we just keep it for week for week 3, week 1?
Okay, ma'am. Then the discussion
Won't
of
week 0 be there for evaluation?
Week 0 won't be there for evaluation.
Okay.
Can you still just go through
ma'am,
variable
then
PMF one?
when to discuss, ma'am, then is there will be another link to discuss that week 0 problems?
Week 0 problem. No, basically we'll be discussing week 1 in all the sessions.
So can you explain, ma'am, please, this question?
Let me check. Which week? Week 0, part 3.
Yes, ma'am. Week point 3, tutorial 3, question number 4.
Tutorial 4. Tutorial 4, right?
Tutorial 3, question number 4.
Ma'am, I'm having one doubt that where we have to submit that Google site.
You didn't get any form yet? Okay. So, okay, we'll check with that.
Okay.
Ma'am, could you once go through random variable and PMF?
Random variable and PMF.
Yes, ma'am, I have some doubts in there. Just a quick recall would be fine.
Which lecture it is?
Random variable.
Yeah.
I think it's week 0, part 3.
Okay.
First lecture, ma'am.
Okay, so what do you want me to explain there?
Ma'am, just go through, ma'am. From the basics, go through.
Okay. So, what is a random variable?
Assigning samples, elements from sample space to a variable.
To variable? No. So, random variable is a function from the sample space to real line. Right? It is a function. Random variable is a function. It's a function from your sample space to some real line. So if I, let's say, toss a coin 3 times. Okay, so let the random variable is tossing a coin 3 times, and now if I'm interested in like number of times head will appear.
Okay.
So what all values it can take?
0, 1, 2, 3.
0, 1, 2, 3. Right. So if I'm tossing the coin 3 times, what is the possible sample space? It is head, head, head. All those sample space you can write. There are 8 outcomes in this sample space.
Yes,
and so it is like a function. So you have those outcomes, and each of the outcomes has some probability assigned to it, and so these are the outcomes, and you are interested in number of heads. So it can either be 0, 1, 2, 3. So just write 0, 1, 2, 3. This is a range, and so this is some function x, which is random variable. So if I write h, it means number of heads is 3, so it will map to 3. If I write h2, hht, so there are 2, so it will map to 2. So it is just like that. So this is what you mean by random variable. So it is just a function from sample space to real line.
All right.
Now we talk about probability mass function. So so if you look at, so probability mass function is basically that we call as PMF. So that is probability that the random variable is taking some value, like for whatever possible values x has. So in this case, it has 0, 1, 2, 3. So if you find the probabilities for each of the corresponding x values, if I write what all value, so if you write the corresponding probabilities value for each of the x. So this will be considered as the PMF of x, probability mass function of x. Right? So if I look at binomial random variable, if I say, let's say x is a binomial random variable, so PMF of this probability x equals k is n choose k p to the power k 1 minus p to the power n minus k. So this is a PMF of a binomial random variable where k is taking the value from 0 to n. This is just a PMF.
Okay.
So week 0 basically is for your practice. You just go through it. Most of the part you already know. So just focus on the part Poisson distribution because that is not covered. Read Poisson distribution, geometric distribution, and some.
In week 0, there is a problem of geometric distribution. So only
Yeah.
I was asking because it's not taught now.
Okay, that was geometric distribution. Okay.
Could you also explain Poisson distribution?
Poisson distribution we have discussed in the beginning.
Ma'am, so when you will explain this or
Yeah,
Can you explain the difference between PMF and Bernoulli trial?
what? PMF and Bernoulli trial. So what do you mean by Bernoulli trial?
I think a series of, it's either success or not success kind of thing.
Yeah, so it is not a series of trials. It's like Bernoulli trial means given any trial you have, either it can, like you have defined some success. So either it is a success or failure, depending on how you have defined your success to be, the random variable. So it can take only two values. So either 0 or 1, either success or failure.
So a binomial random variable is just a series of Bernoulli distribution.
Binomial random variable is a series of
Bernoulli.
sum of yeah. So like you have n repetitive Bernoulli like you have n independent Bernoulli trials, and you are just trying to model the number of successes that you will get in n independent trials. So that is just you'll just do the sum over. Like sum of Bernoullis are binomial.
All right, ma'am. All right. Thank you.
Yeah.
Ma'am, can we explain
Next,
activity question
question number
1.3,
4.
question number 1?
Question number 4. Yeah. Okay. So just given x is a geometric distribution, fx is x by 2 if x is an even number, and x equals fx is x plus 1 by 2 if x is odd or even or odd. Okay. Find the probability that fx equals k. Probability that fx equals k, where k is in the range of fx. So your x is geometric P. So what is the distribution? Probability x equals k will be 1 minus p to the power k minus 1 into p. Now
Yes, ma'am.
fx is given to be x by 2 and x plus 1 by 2. If x is even and if x is odd. Now you have to find the distribution of fx equals k. Okay, so let's take first the even number. So if x is even, it will take, so in case of even, this is going to be x by 2 equals k. So okay, so this is in case of x is even. So this is going to be probability x equals to 2k, and we know that x is a geometric p distribution. It means on 2k success, you should on the 2k trial you should get the success. So that is going to be what? That is 1 minus p to the power 2 times. It should be
2k
2k
minus 1.
minus 1 into
P power 2k. P power 1. P
into
power 1.
p into p. Yeah. Now, if you take x to be odd, so probability fx equals k, it is going to be probability that x plus 1 by 2 equals k. So this is x equals 2k minus 1. So this will be 1 minus p. 1 minus p to the power 2k minus 2 into p. Right? So this is correct, right? Minus 2 into p.
Hello?
Yeah.
Nothing, ma'am. I thought I lost connection.
No. I am there. I am just.
Which problem are you discussing, ma'am?
I'm discussing week 0, part 3, tutorial 3, question number 4. I'm doing something wrong.
So, ma'am, in stats
Can
2,
we,
there are tutorial questions instead of videos. Is it?
Instead of tutorial videos, yeah, there are questions that you have
So,
to.
ma'am, can we take average of these both probabilities?
It is not like that. First, we should find the range.
Okay.
So first, we'll find the range of fx. So x is geometric p. So x is taking a value from, it will start from 1, 2, 3, 4, and so on. Now for x equals 1, so since x is odd, it will take 1 plus 1 by 2. So this is going to be 1. For x equals 2, it is going to be again 1. For x equals 3, it is going to be 2. For x equals to 4, it is going to be 4, 5. So, okay. We'll go like this. So what is the range? Range of fx.
Ma'am, if
Range of
x goes
fx
to
is
infinity, then range of fx also goes to infinity only, ma'am.
1, 2, 3, and so on. Yeah.
Yes, ma'am. It will go to infinity.
Now, what is the probability of fx equals 1? So fx equals to 1 we got from x equals 1 and x equals 2. So this is probability x equals 1 plus probability x equals 2. What is this? This will be p time p plus 1 minus p into p. Correct? Now, what is p of fx of 2? So we got 2 for x equals 3 and x equals 4. This is probability x equals 3 plus probability x equals 4. So this is 1 minus p to the power 2 into p plus 1 minus p to the power 3 into p. So it will go on like this. Now, in for general k, fx equals k, it will be
1 minus p to the power k
1 minus p
to the power k into p.
Yeah, to the power k
Into p plus 1 minus p to the power k plus 1 into p.
Plus 1 into p.
Yes,
What
ma'am.
is the answer given?
Ma'am, answer is somewhat complicated only, ma'am. 1 minus p raised to power 2 k minus 1 p into 2 minus p.
Okay. Can you tell me the answer?
What, ma'am?
Can you tell me the answer?
Answer, let me check, ma'am. Ma'am, the answer is 1 minus p to the power 2 times of k minus 1 into p into 2 minus p. Hello,
Yeah,
ma'am.
tell me, yeah.
1 minus p to the power 2 times of k minus 1
Okay.
p into p into 2 minus p
P into p.
into 2 minus p into 2 minus p.
This.
Yes, ma'am. This is the answer.
Okay.
And I
If
think you
we
can
can
take 1 minus p to the power k common and then
If we can simplify, it
Yeah.
may come. So 1 minus p to the power k, take common p. So 1 plus 1 minus p into p. So it is what 1.
Ma'am, it will be 1 minus p only, not into p. At least actually you took that p common, ma'am, outside.
Okay, sorry.
So it will be 2 minus p into p 1 minus k to the power k. No, still not matching, ma'am.
Just 1 minus p. So this is 2 minus
P into 1 minus p to the power k. But it's not.
Okay, I'll just check this question. Maybe somewhere calculation is wrong.
Yes, ma'am. Actually, this question was a bit tricky. That's why I was trying to ask it to you.
No, the
That's why.
process is correct. First, you should find the range and then try to find the value and just try the general form. So one thing you can do is you can write this question, put this question in discourse, and just tag me. I will check the answers.
Ma'am, what, ma'am? Can you please repeat it? What you said, ma'am?
You can post it out on discourse and just tag me there. I will answer there.
Okay, discourse.
Maybe on discourse. Yeah. Maybe somewhere calculation is wrong.
Okay, ma'am.
Yeah.
Hello, ma'am.
Yeah.
Ma'am, I have a doubt. Ma'am, please, can you draw a joint PMF of take any value?
Okay, you want me to draw like how to plot like sketch?
No, ma'am. Draw a PMF. I have a doubt on that. So please, can you draw any example?
I couldn't understand.
Okay.
What you want me to do is like how to draw a table.
No, I don't want to draw.
Okay.
Can let
You
me
want
ask a question.
Patient, can you?
How I can find P of y? P of y of taking y in the range from 1 to 3.
P of
Uh,
P of
P of y.
You can say, okay, probability of y equals
Y.
some k,
And
where k is in the range of
K
y.
is from 1 to 3. K is from 1 to 3.
Range of y is 1 to 3.
3.
And what x and what do you want to do is, like, it is given to you that xy is jointly distributed.
I'm unable to explain. Let me frame the question. Meanwhile,
Because if you just give me this, like, how can you find the probability that y equals k?
ma'am, I'm unable to frame the question. Meanwhile, you take another questions until I frame it.
Okay. Fine.
Activity, ma'am, week 1, activity 3, question number 1.
Activity 3, question number 1. I think it's the same kind of question we discussed in activity 1, right? Activity 1.1. So in this case, you just have to find fx given y equals 1 of 2, correct? Where x is the number of queens drawn and y is the number of king drawn. Can you tell me what should we write? What is
Ma'am,
the
4C2, just a minute,
no.
4 part.
No. I'm not asking you exact thing. Like, if I write f of x given y equals k of let's say t2 of t1, what is the formula? What will you write here?
Just a minute. Ma'am, it would be the marginal PMF of x, comma of all terms in the sum of T1. That in the
No. What is this? This is conditional.
Yes, ma'am.
Conditional is joined by marginal, right?
Yes.
So what is joined? So this is fx of y of 2, 1, right? Divided by
Ma'am, total marginal of this table, ma'am.
which table?
Ma'am, that we have to create a table
Summation
before.
of f of 2.
No. Let him speak. Yeah. If I write f of x given y equals 1 of 2, what does it mean? It means that probability that x equals 2 given y equals 1. This is fine.
Yes, ma'am.
So what is this? This is a conditional probability. Given y, you have to find the probability of x equals 2. So what is in general formula for conditional? What do we do? It is
generally
joined by marginal, right?
Yes, ma'am.
So if let's say you have two events A and B, if I ask you what is probability of A given B, what is this? What is probability of A given B? A and B are some events from the random variable. What is this?
Ma'am, A event has occurred and B event has occurred.
B has occurred. What is the probability of A? What is the formula? What do you write here?
Ma'am, P A upon A intersect P A intersection B.
No. P probability of A intersection B divided by probability of B.
Probability of A.
The event, not A, B. The event that has occurred, the event that you have observed. Right? So this has, you know that the event B has occurred, that goes in the denominator. And in the numerator, the probability of both the events occurring together. That is what we write. So if I write probability of x equals some small x and y equals some small y, what does it mean? It means you have to find the probability of occurrence of both these, like x equals y equals y should occur together. So this is nothing but joint probability, joint distribution, right? Joint probability.
Yes, sir.
So similarly here we can write as f of xy of 2, 1 divided by
2,1 fx. The condition, the y is f. So f y should be in denominator.
So in the denominator, it is fy of 1.
Yes.
Right. This part we have already found in our previous activity. That is right.
Yes, ma'am.
Huh?
Actually, ma'am, I joined late,
Ma'am,
so I have
please
not
explain
checked it.
again.
See, what is fx given by equals 1 of 2? This is probability that x equals 2 given by equals 1. This is conditional. This is a conditional. And what is the formula? This is joint by marginal, right? What is joint distribution of x and y? Joint probability of x and y, that is f of x by 2, 1. And this y equals 1 has occurred. So that will, this marginal will put like take into the denominator part. And this part we have already calculated fxy of 2, 1 in the activity 1.1 that we have explained there. Let's go back.
Actually, ma'am, I joined the session late. I didn't see the time right.
Yeah, see, this one, fxy of 2, 1, right? So there are, what is mean by fxy of 2, 1? It means there should be 2 queens and 1 king in those 4 cards. What is the probability of that? So out of 4, there should be 2. So there are 4 queens, right? In a pack of 52 cards, there are 4 queens. There are 4 kings also, right? And what do you want? You want your x to be 2, number of queens to be 2. So out of those 4 queens, there should be, how many ways you can select those 2 queens? So it is 4.
Ma'am, 4C2.
And how many ways you can select 1 king?
1 king is 4C1.
And since you have withdrawn 4 cards and 2 plus 1, 2 queen plus 1 king, make it only 3. You have 1 more card left to be drawn, right? So how many ways you can select some other card?
52 minus 4 minus 4 is 44. 44 C1.
Yeah, divided by 52 C4.
Yes, ma'am.
Right. Now you have to divide. You have to just divide this by fy of 1, right?
Yes,
correct? There, if you see, it is fy of 1 that you have to find. Right? So how will you find fy of 1? What is mean by fy of 1?
Ma'am, fy of 1 is probability of 1 king in the
Probability of getting 1 king. What will this probability?
ma'am, 4C2 4C1. 4C1 by 52C1.
52C1. No, you want 1 king, right? So
yes,
4 choose 1, but there you have drawn 4 cards.
Yes, yes, ma'am. So 48C3 also would be there.
48C3 and this is 52 choose 4. So just divide this by this. You will get your answer.
Yes, ma'am.
Hello, ma'am.
Yeah.
Can you explain practice assignment 1, question number 5?
Practice assignment 1, question number 5.
That question related to I plus 2j whole divided by c.
Yeah, just hold on. Okay, what is the problem there? Did you try to solve this problem?
I tried but unable to get the answer.
Okay, just let me write the problem.
And ma'am, in same activity, 7th question also.
Okay. I'll first write the question. You just tell me what you have done. So the question says your random variable x and y are taking the values in 1, 2, 3. They have a joint PMF that is x, y, and it is given by, so probability x equals I, y equals j to be I plus 2j by c. You have to find probability that x is less than 3 is less than 1, y is less than 3 is greater than 1. Yeah, can you tell me what you have done here?
I've calculated the PMF table, joint probability matrix that I've calculated. And after that, what
I will
should be the next step?
I'll make a joint distribution table. So what are the values x is taking?
It's taking them 1, 2, 3, and y also taking the same.
1, 2, 3.
Okay.
That's this is 1 plus 2
that
by
is 3 by 54. I've calculated all the things, and that is 3 by 54.
C is coming out to be 1 by 54.
C is coming 54.
C, yeah, sorry, 54.
Yes,
so C is coming out to be 54.
Yes, ma'am. And P
Now,
of x.
okay. So P of x lying between 1 to 3 and y lying between 1 to 2 to 3, basically. You
So
have to find this probability, right?
Yes, ma'am.
So what are values of x here? So x can take both. So x is lying between 1 to 3. So it can take either one.
All the values, ma'am.
All these values. Y
take only 2 and 3.
2 and 3, right? So you just, whatever values you will get, you just have to add those values.
Okay. Adding will give the answer.
Yeah. Did you try that?
I've tried. It's coming out. It's coming 42 by 54, but I was not sure that my the solution is correct or not.
Your answer is correct.
I have not submitted yet.
But
I'm not sure with my process. What process I'm.
Not a graded assignment. You can submit it. You can write again. It's not a problem.
Okay. So adding all the values will give the answer.
Yeah, just try that.
Okay.
It's activity problem, so you can submit any number of times you want. There is no restriction.
And ma'am, in same activity, question number 7 also.
Same activity. This is a practice assignment. Okay?
Oh, sorry, I have practice assignment. Question number 7.
Okay. Question number 7 is from. Okay, what is the problem here?
Question number 7. I'm getting a wrong value. The probability which I'm calculating is greater than 1.
Greater than 1.
Yes, sir.
That is not possible.
I have calculated the value of k, that is k coming out to be 1 by 20.
K is coming out to be 1 by 20. Okay.
Yes,
6 you have done. So what is the answer for 6? You have to find the range of y.
Range, ma'am, range is 2, 8, and 18. That last option, I think.
Wait, so z is x square of y. Z is x square of y.
Square of 5, yes, ma'am.
So given y equals 2, y will take the value 2. Z is taking the value 2x square.
Ma'am, can you share the screen?
Yeah, wait, I will just first write the questions on this. You have not received the solution for practice assignment. Yeah. So this was a table. This is 1, 2, 3. Y is also taking the value 1, 2, 3. K is coming out to be 1 by 20.
1 by 20. Yes.
So 1 by 20, 1 by 20. This is 2 by 20. In 2 by 20 is 0, 4 by 20, 3 by 20. This is 1 by 20 and 6 by 20. It is adding up to 1. 2, 4. Yeah. Now the first part is, so your z is another random variable that is defined as x square of y,
So,
and you have to find the range
range of that.
for z given y equals 2.
Yes, ma'am.
So given y equals to 2, your x is taking the value 2 by 20. So your z will become 2x square. So x is taking the value 1 and 3.
Right. Yeah.
Yeah. So the range of what it will be for x equals 1, it is going to be 2, and for x equals 3, it is going to be 18. So this is going to be the range for y equals range for y given y equals 2. This is 2 comma 18. Right? This
Yes,
is
ma'am.
the range.
Yes,
Right.
ma'am.
Now we have to find the next question to be probability z equals 18.
18 given y is equal to 2.
2.
Yes, ma'am.
What is this? This is probability z equals 18 comma y equals 2
Whole
divided by.
divided by p of y equals to 2. Yes, ma'am.
Yeah.
So x square of y equals 18, y equals 2, about y equals 2.
So we can conclude that x equal to will be 3.
X square, right? Y equals
Yeah.
2.
Yes, ma'am.
Yeah.
Possible.
Because
Then
y
only
is given 2.
Yeah.
Yeah.
p is equal z equals so it should be
I think now easily he can do 4k upon में 2k plus 4k. I think 2
Yeah.
upon
So
3. Yeah.
yeah.
okay. Now I can do it. Okay.
Right.
I have done some mistake in sync.
Yeah.
Okay, thank you, ma'am. Thank you.
Yeah.
Okay.
Okay, anything else?
I'm just a general query. Can I ask?
Okay.
In this term, what we have read in the term 2, we are reading in week 1 only. In term 2, that was given in the week 3. So is the syllabus is increased by 2 weeks?
No, syllabus has not increased. So if you look at the previous term syllabus, so
Yeah.
regression part was not covered.
Okay,
So
fully not
this,
covered.
yeah, so this time you will read regression, and so week 1 and week 2 is going to be multiple random variable for discrete case.
Yeah.
Then you will go to week 3, that is going to be your expectation, variance, covariance, correlation.
Correct.
Week 5 you will come across, week 4 you will come across the continuous random variable.
Yeah.
And week 5 there will be multiple random variable in the continuous and discrete case. Okay.
Yeah.
And then week 6 will be refresher week. So whatever is covered till week 6, we'll put some questions or something for a refresher week. You can just go through the content from week 1 to 5.
Sixth one, right?
Yeah, 6th one. And from
Yeah.
week 7 onward, it's the same thing, that whatever it was previously.
Okay. Okay.
Ma'am, I have a question for activity 4.
Activity 4. Which question number?
The last one, I think it's 6.
Okay.
So it gives the third one as the answer, but I was not able to understand why.
Which question? Last one. 6th. Identify the joint PMF of X and Y. This one.
Yeah.
What is the problem here?
So I couldn't understand why this is third option. So when I draw one card and yeah.
Look at the 5th question. So if you look at the third option, let's show the screen.
Can you tell me which question it is?
It is activity 4 class question.
Okay. From week 1, right?
From week 1. Yeah. So your X is uniform 1, 2. Y is number of faces obtained from a deck of well shuffled 52 cards in X draws with replacement. So we know that Y from question 5, that given X equals 1, Y will take Y has a binomial distribution with n equals 1 and p equals 1 by 13. Right? So given I have to find the joint PMF of X and Y.
Sorry.
Wait. So X is uniform 1, 2. And Y given X is binomial distribution. So this is A comma. What is Y? Number of
Aces.
number of aces. Okay. So it is going to be 1 by 13. Now, yeah, let's see. X is only taking 1, 2.
Yeah.
Y can take 0, 1, 2, right?
Yeah.
Now, if we have to find probability X equals 1, Y equals 0. So what we can write it as f of y given x equals 1 of 0 into probability of x equals 1. Correct?
Right.
Right. And what is this? This is a binomial distribution with n equals 1 and p equals 1 by 13.
Right.
Right? And this is going to be 1 by 2 because this is uniform and 1, 2. Correct? So this is going to be what? 1 choose 0, 1 by 13 to the power 0 and 12 by 13 to the power 1 into 1 by 2. So it will be 12 by 13 into 1 by 2, that is 6. 6 by 13. Right? Similarly, you can find for each of the xy's.
Okay. Okay, I'll try this one.
Yeah. Anything else? So all of you are doing this first time, right? Starts to.
Yes, ma'am.
So there is no one who has dropped last time and took the course this time. All are new students.
Yeah.
Ma'am, one minor doubt. Ma'am,
Yeah.
for quiz one and quiz 2, the syllabus would be once 3 week or would be changes like last time? In last time, the syllabus was once to 4th week, and for second quiz it was 5th to 9th week onward.
Starts 1.
In ma'am stats 2.
Okay. So about the syllabus for quizzes, you must have gotten the information. So quiz 1 will be 1 to 3, and remaining you will be informed.
It will not be included that those week 0, part 1, part 2.
Week 0, part 1, part 2, part 3, it is there for you to just read because most of the things are from the starts 1. You have already seen all the topics in starts 1. There are few topics that you haven't seen, like Poisson, symmetric, negative, binomial. So you can read those parts because we will be using those concepts later in the week, as you have seen in week 3. So it is important for you to know the concepts, but directly from, like, a direct question will not be there. Like, those parts will be involved somewhere in the questions,
Yeah,
but
obviously. Yeah. Thank you.
so, yeah. Anybody has any more doubts?
Just one thing, ma'am. When will be the next session? Because we have not completed this week whole complete course by now. So when we completed, we will able to have what we have doubts, ma'am. We just completed till 6.
Okay, so one more session. It must be updated on our calendar. So
Ma'am, actually calendar is not updated, ma'am. Is it not showing in when we attach the calendar with our Google Calendar?
Okay. Okay, I will check on that. Just let me check here.
For me, it is showing on Monday.
Yeah, it is on Monday.
Yeah, 7 to 9, right?
Yeah, 7 to 9.
Yeah.
Okay, ma'am, I'll check it, ma'am. Then.
Yeah, it is updated. Calendar is updated. Even I can see it. So, and the next.
Maybe I tried on second on the 6th September. Maybe that's why it's not showing that time.
Okay, fine. So the next session will be on Monday, and next will be on Tuesday. After that.
So, ma'am, Monday session will be of about week 2, or it will be for week 1, week 2 both?
Week one,
right?
So till Tuesday, it will be for week 1.
Okay, till Tuesday.
Yeah.
And after that, there will be session for week 2, right?
Week 2, yes.
This is the first session for stats, right?
First session for stats too, yes.
Correct. Okay, thank you.
So, nobody has any doubt. Can we close the session then?
Ma'am, actually, I have a minor doubt that I couldn't able to find that how to identify that whether it is independent of another thing or not. Theoretically, numerically, I can do, but theoretically, I cannot able to identify these things.
Independence. Okay. Can you give one example?
It was from some assignment. Let me find it. Like it was looking like it was independent, but it wasn't.
Okay. Yeah, just give me one example so that I can explain.
Yeah. Ma'am, practice assignment 0.2.1.
Yeah.
Question number 2.
0.2.1.
It means it was from week 0, part 2.
Question number?
2, ma'am.
Suppose that we roll a pair of paired dice. So each of the 36 possible outcomes is equally likely. You denote the event that the first die shows 5. We denote the event that the sum of the outcomes of rolling the pair of dice is 10. And C denote the event that the sum of the outcomes of rolling the pair of dice is 7. Okay, what is the answer for this question?
B and C, ma'am. Event A and event B are not independent, and event A and event C are independent.
B and C, okay.
Yeah, so numerically I was able to solve it, but like objectively, or you can say theoretically, I wasn't able to fill the question or even find the answer.
Okay, so A is the first die shows 5, and B is sum is 5, sum is 10. How you can understand it as? Just hold on.
So for E, I think we can write like there could be like 5 in one die, and for another die there could be 1. Like for another thing, like 5 and 2, 5 and 3, 5 and 4, 5 and 5, 5 and 6.
Just give me a minute.
Yeah, sure.
Karthik. Karthik, you are there? Yeah. Who was saying? Ayush, is it?
Yes, ma'am. Yeah.
Yeah. What were they saying?
What was I saying? About what? About event A, I was saying that there could be like for the first die, there is clearly given that that should be showing 5, right? And for another die, we can take for event A, like on first event we can take 1, for another we can take 2, 3, 4, 5, 6. Like there will be like A is the event that first die shows 5. So we can take like sample space like 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. Right?
Yeah.
So I'm saying that I am able to solve this question numerically, like from formulas and everything, but I'm not able to feel the question like
that
like
they are.
yeah, like whether it is independent or not. Like I want to solve this type of question like without using those formulas. You know what I mean?
But sometimes it just looks like they should be independent.
Yeah.
But if you try to like
it is
calculate
not.
it, sometimes it may not be independent.
Yeah.
So
That's what I wanted to clarify, that because there is a very simple definition of independent, that if it is not depending on that, then it is independent, right? So that should be very clear by the question, that if it is depending on this event, then it is dependent. If it is not depending, then it is independent.
Yes.
Yeah. But I think I'm not able to solve this question by this theory.
Yeah, theoretically it's a little difficult.
Yeah, that's what I was saying. And by that thing, I am able to solve it, that A intersection B, if it is not equal to probability of A into probability of B, then it is not independent. And if it is equal, then it is independent, right?
Yeah.
Yeah. So that part is clear. But objectively, I cannot able to solve it. That's what I was saying.
Okay.
So can you suggest me something, or I should go with the numerically thing only?
Numerical part, yeah, like for now you can just try.
Because the thing is, it is just that I'm not able to feel it, that what is independent, because there I'm not feeling it is independent, and by that formula I'm getting that it is independent, you know, like sometimes I'm getting it is not independent, and by formula
I got it. Yeah, I got it.
Yeah, that's it. Otherwise I'm good with the
problem. Okay. Yeah, like I'll try to think of some explanation.
Yeah, sure, ma'am. Thank you so much.
Yeah, thank you.
Ma'am, I have one doubt. I can't clearly get the idea of the question. Can I ask you?
Okay.
Ma'am, I remembered it was in activity of week 0 part 2, activity 10.
Week 0 part 2.
Activity 10.
Conditional probability.
Yeah, ma'am. It was of question number 5.
Okay. Each set of a 3-set badminton match between Himanshu and Hari is won with equal probability by either player. What is the conditional probability that Himanshu wins more sets than Hari, given that Himanshu wins the first set? You try to solve this problem?
Yes, ma'am, I did. The problem I'm facing is I took the, say, for example, the event B is Himanshu won the first match. And event A is Himanshu wins more sets than Hari. Since there are 3 sets, so he has to at least win 2 of them to win more than Hari. So I wrote all of them down.
Okay.
When I wrote all of them down, both event A and B, the size, the cardinality of that set is 4. I checked it, so both are 4. And now when I use the conditional probability, like probability of A given B, and as I'm putting it, like A, probability of A given B is probability of A intersection B divided by probability of B. So probability of A intersection B is 3/4. That's what I'm getting.
A intersection B means what? That Himanshu wins.
Won the first match and also wins more than Hari, like at least 2.
Yeah, Himanshu wins the first set.
Yeah.
And Himanshu wins more sets than Hari. So Himanshu should basically wins 2 sets. 2 like either 2 or 3.
So ma'am, since that I do that, like A intersection B is 3/4. It's coming, and probability of B is 4/8 or 1/2. So when I do that, the end result comes 3/2, which is not possible, right?
No,
I can't get around it.
You may I think see how are you getting 3/4? You are restricting that Himanshu is winning the first set, correct? Hello.
Hello, ma'am. Can you hear me?
Yeah. So there you are restricting that Himanshu is winning the first set. Then you are getting 3/4.
Isn't 3/4 the correct answer?
Yeah, that's what.
3/4. Why is
Because
that?
you are already restricting, right? To get 3/4, you are already restricting. Like Himanshu has won the first match. So what is the probability that he will won more than like more sets than Hari, right? So either 2 or 3. So there, if you fixed like B2, like Himanshu has won the first set, then you are finding. So you are actually finding the conditional probability.
Yes, ma'am. So because I'm doing the intersection, right?
No, that is not the intersection. That is like that is conditional probability. What you have found, that is the conditional probability.
That is the conditional probability.
That is the conditional probability. If you write A intersection B, means both the events should occur together.
Yes, ma'am.
Right? But if you write A given B, it means B has occurred. Now what you're saying is Himanshu has already won the first set. And now you want to find probability A given B. And there you're getting 3 cases. Right? So that is 3/4.
Oh, I'm getting 3 cases where he won the first match and won at least two matches.
Yes.
So, ma'am, so dividing by probability of B is not necessary.
No, because you are already finding conditional there. Yeah, so you don't have to do
like
anything.
then probability of B is like 1.
No, that is not probability of B.
So
just let me solve the question. So how did you find the four conditions there?
4 conditions for
you had found there are 4 cases.
Yes, ma'am. I found 4 cases for both the events. Like Himanshu won the first match. There are 4 cases where he won the first match, and Himanshu wins more than two sets or more. I have found 4 conditions, 4 events like that, outcomes. So both events are 4.
Karthik, can you stop the live streaming? Yeah.